Jingqie is having a CCA camp today. And Fuqin, I'm not too sure. We may just turn out later. Okay, this one is but I think you remember your lower side convection, conduction. Yeah, this is just expanded on the same concepts. Okay, for you, first thing first, this is important. This is primary school concept. Is heat transfer is always from high to low temperature. And there are three types. Okay, three types of heat transfer: conduction, convection, and radiation. I assume you still have some recollection of them, right? Okay. Okay, so this is the first one, second one, convection, and third one, radiation. I assume you should be able to tell radiation. Okay, important. When does conduction happen? Mainly in solids. Solid. Okay, so take look at your question carefully. Is it talking about solids? If it's solid, confirm. If it's true solid, confirm it's conduction. Okay. Now, also the other thing, maybe you think it's not important, but it can be conduction in any direction. As long as it's in a solid, it can go up, down, left, or right for the heat transfer, as long as there's a temperature difference. Again, take note of this word medium. All right, medium means a matter. Okay. So that means actually conduction can also take place in liquid and also gas, but it's not so effective. Oh, but tell me why. I didn't write the answer here. Why is it most efficient in solids? Sometimes they will actually ask this. Why not liquids or gases? You're on the right track, no? In salt, what's the difference between particles in the solid and particles in the gas?
Like very but then gases are not their parts.
Yes, good. Right, so there comes to this part here. Okay, basically in solids, particles are vibrating, right? And that also means the vibrations can actually propagate. Let me see. That means, let's say, imagine this part is hot, they vibrate more vigorously, right? So the vibration will actually pass it on to the cooler region. Okay, simple as that. But there's one more thing. For metals, can you just jot down? For metals, they have what you call free electrons. Only for metals. Actually, no need to know for physics, but basically these free electrons are the valence electrons. You know what are valence electrons, right? Okay. Though physics will not ask you about this word valence. Okay, so free electrons meaning that they can move throughout the matter. This one you have to know though. Move through the matter. Or let me be a bit more precise, free to move throughout the matter. So that means imagine this part is hot. So the electrons are moving fast, so they can move all the way to the cooler part of the matter. And along the way, they'll knock into other particles that causes vibration as well. Okay. Just a note, Devon. In a matter, there are atoms, but the atoms are fixed. Remember, they're fixed in position, but the electrons are not. Electrons can move. Those so-called free electrons. Okay, take note of that. So for you, if your question is talking about matters, you have to talk about the atoms vibration and the free electrons moving, both. But if it's only about just normal solid, then it's only the vibration. Okay, convection is important in fluids. And in fact, only in fluids. They want to tell me what are fluids? And yes, liquid or gas, they are known as fluids. Then this is the model answer that they want you to reproduce all the time. First step, the hot or the warm fluid expands. All right, expands means volume increases. Pick one, day one. What's the formula for density? Okay, good. So mass is the same. Volume increases. So what happens to density? Yeah, okay. Write that in your answer too. Density decreases. Means it's going to be lighter. So your fluid will rise. Okay, your fluid will rise. But it can't rise forever, no? Correct. When it has risen high enough, it would have lost heat. Okay? And this is actually your heat transfer. That means from the bottom, it rises up and then it loses heat along the way. Okay? But that's not the end. Normally, they want you to continue the story. So what happens to the surrounding? Maybe you just write this down first. The cool fluid nearby will sink because it's denser, it's denser. Okay, so when it sinks, remember the bottom is hot. All right, so basically once it sinks low enough to the bottom, it will gain heat because of the higher temperature at the bottom. Yeah. So it looks like this. This one is quite standard, so try to remember how it works. I have a pot of water. You heat at the bottom. Okay, remember it rises because it's hot, so density decreases, it rises. But once it reaches the top, it would have passed its heat to the surrounding, so it becomes cool again. But at the same time, this is cooler here, so this cool water will sink. From both sides. But don't forget, once it reaches this part, it gets heated up, right? And so it will rise again. And of course, you can probably join the dots. So as it cools, it will go. Let me use the other one. So this goes to the top, it goes back to the bottom, rises to the top, goes back to the bottom. So it forms a cycle. And there's a name for that. Make sure you use the name for your answer. So this chunk here, they are called convection currents. Okay, so make sure you use these two words in your answer. Convection currents are created. But last point, important. Convection only transfer heat upwards from bottom to top. It cannot transfer in other directions. Remember that. Now, which means what? Which means that if I have this case, same thing, I have a pot of water. And I try to heat it here. Okay, for this case, my heat is at the top now. So where is the, there's no convection going on. Yeah, okay, so sometimes this can come out. So it means that there's no convection. But eventually it still become hot here, right? The heat still eventually travel downwards. How? By what process? Conduction. Okay, conduction can still occur in the liquid. But what you need to know, also sometimes you ask, conduction is slower than convection in a liquid. This has been asked many times, so it takes a long time to heat up the bottom. Okay, then last one, radiation. Okay, Devon, for those open-ended questions, when it's you know that it's a heat transfer question, make sure you use one of this or even more than one. Conduction, convection, or radiation. Make sure you know which one. So last one, radiation. What is radiation? It's basically infrared waves. Let me add in the word waves. Basically, these waves carry heat. But important, this is super important, does not require a medium. It does not need to go through metal. Or it does not need gas, liquid, or solid. It can, but it doesn't need. All right, so therefore it can go through vacuum. Devon, do you understand what's vacuum? Yes, sir. What is it? A what? No. Okay, make sure you understand. Vacuum means totally nothing, as in outer space. There's no air, no water, no solid, nothing, empty. That's a vacuum. Maybe I just write down as well. Basically, vacuum means no matter at all. Okay, example, outer space. So I think the best example they like to ask is, let's say, think about this. Let's say the sun. Okay, then you have Earth over here. And make sure you realize in between is actually vacuum, no? There's nothing in between the sun and the Earth. But of course, heat from the sun still reaches the earth, right? So make sure you can answer, or in the answer you write is by radiation through the vacuum. Okay, just a few more things. Yes, radiation is most efficient in a vacuum. In air or in a gas, it's still quite efficient. All right, it can still go through air. Right, that's why from the, atmosphere is air. So that's why sunlight can still go through. But in a liquid, radiation doesn't work so well. Okay, basically the liquid will absorb the radiation. In a solid, even worse. All right. Okay, most solids will block radiation. Most, except for a few, but you don't have to know those. Okay, last, okay, this one is important. There are 2 words you need to know. Actually, 3 words. I'll tell you the third one later. One is emit, one is absorb. Okay, take note of these 2 words and one more word. Let me just draw for you. Okay, imagine you have this hot object. Hot, so it's hotter than the surroundings. So where's the heat transfer? From where to where? Which is hotter, the object or the surroundings? Object, right? Okay, so in this case, you will have heat transfer outwards, correct? But imagine this is air, no? It's surrounded by air. How does it transfer the heat? Conduction, convection, or radiation? Yeah, okay. Air, still radiation can still work. And therefore, it is giving out. But we don't use the word giving out. We use the word emitting radiation. But on the other hand, be careful here. What if I have this situation? Here I have a cool or cold object, but the sun is up here shining brightly. Where's the heat transfer? What direction? Yes, good. Into the cooler object. Now, of course, in this case, I don't call emission already. I'll call it absorbing. radiation. Okay. Again, it's surrounded by air. It doesn't have to be cold, just normal room temperature. That'll be good enough. Okay. All right, so take note of these two words, absorption and emission. Okay, this one, you surely ask one. What are the 4 factors that affect radiation? Confirm you ask. Just that which factor they will ask you. Okay. So these are the 4 factors. 1, 2, 3, 4. David, you just read the rest first because yeah, you need to know all 4. Let me just keep this.
Right, I'm going to ask you about the report. Yeah.
Huh? Have you finished writing? So, by the way, anything that's a good emitter is a good absorber. Keep that in mind. So let's say if this object is black. Okay, black. So it's going to emit a lot of radiation. Okay. Now, likewise, imagine this object is black also. Yes, it will absorb more radiation. Okay, but the other thing I didn't mention is what if this object is what? It doesn't absorb much, right?
It's not.
Yes, but what happens to the other radiation? It doesn't absorb. Instead, that's the third word you need to know. It reflects. So basically, if this is a white object, the radiation is reflected. Yeah, because take note, the sun is still there, so there's a lot of radiation falling on it, no? Basically, it's reflected. Take note of that word. So reflected instead. Most radiation is reflected. Okay, so maybe I'll just post it to you in another manner. So essentially, maybe you take note of it because they can ask about all these words. Essentially, a good absorber is a poor reflector, correct? Right, so, and of course, a poor absorber, yes, is a good reflector. So make sure you understand this. Okay, good reflector. But let me rephrase it. What if I tell you it's a good emitter? Is it a poor or good reflector?
Poor.
Yes, good. Remember, good emitter is a good absorber. So it's a poor reflector. Right, same thing. If I tell you it's a poor emitter, you should know the answer. Can okay. Because sometimes they may not use absorb or emit. They in fact they tell you reflect. Then you must be able to interpret that. Correct. No need for the explanation. Okay, so correct. Oh, okay. Texture, I think you should understand rough and smooth and shiny. I think I don't need to elaborate. Surface. No, I think this is very simple. Imagine if this is hot. Okay, maybe I tell you what. Let me give you an example. All right, imagine I have this object 50 degrees Celsius, and then this object 100 degrees Celsius. Which one emits more radiation? Yeah, very simple, right? Okay, so but of course the reverse is true. Imagine I have another case. Let's say I have a object here, 10 degrees Celsius, and then another object here. Okay, I shouldn't use that color. Minus 10 degrees Celsius. Which object? Okay, first question you ask yourself. Is emission taking place or absorption taking place? Good. How do you know? Okay, so which one absorbs more radiation? Yeah, I understand. Because temperature is lower. Can okay. Okay, next one. Surface area. I think this one is quite easy also. I mean, small area, obviously less radiation, whether emission or absorption, compared to a large area. Okay, that one I don't think I need to draw it out. Lastly, radiation, all direction. Remember just now? How did I draw it? Like that. Okay, it's not just up or down, all directions. As long as it's exposed. Okay. Let me see. Anything else I need to tell you?
So like, no worry. So we find out.
Okay, I think that's about it. The theory part is about this. Others will be all applications already. All right. Okay, I'll give you a worksheet to try out. Hey, guys. I got this. Okay.
I'm not sure about the state of my imagination.
Oh, okay. Come, let's take a look. I think you should be able to deduce, right? 1, 2, and 3, what they are. So, first one. Okay, good. This one. And lastly, yep. Non-matters by the what? Non-matters are. What happens to the particles? Do they move around? What do the particles do? What's that word? Remember your kinetic particle theory? What do the particles do in a non-matter? But of course here, since it's conduction, we are mostly concerned about solids. So the particles vibration, or they vibrate. And try to use that word vibration. What this one? Matters. What do the particles do? They Yeah, so it's also vibration. And what free what? You should know that. No, just now we use a particular term, right? Free what? Yes, free electron diffusion. All right, the free electrons can move throughout the matter. But they want just to be very clear, the free electrons, it doesn't mean all the electrons are free, no? Only a small percentage are free, so keep that in mind. So free electron diffusion, lastly, requires a I mean, well, yes, but to be more general, it requires, conduction requires, what's the word that we use just now? Okay, this one. Make sure you remember this word. It requires a medium, a matter to move through. The rest? How about him? By means of currents. Huh? What currents did we mention just now? There's one word that's in front of the word currents. What currents? By means of. You highlight that, you must use that in your answer. Under convection. Oh, you didn't write down. Yeah. Yeah, make sure you use this word in your answers. Okay, let's go back there. In the what? Yes, good. Yeah, it's the same. Okay, make sure you use that term, convection current. In the what? The, do you say with? Wave? Not exactly. The word wave only comes out in radiation, not really convection. What happens to the fluid? Something changes in the fluid, right? Under convection. Yeah, but okay. But expansion is basically a change of volume. So changes in the volume or density, either one. You can use either word. Yep. Lastly, yes, good. Particularly a fluid. It doesn't work in a solid. Okay. Okay, let me just write down because I'm recording this for them. Okay, last one, radiation. In the form of I didn't really mention this that much except one time. What kind of radiation? Okay, this one can come up in the exam too. For heat transfer by radiation, the specific radiation, because there are actually many kinds of radiation. What? Vacuum? No. Okay. This one, try to remember infrared. Yeah, infrared is the specific kind of radiation for carrying heat. Just be very clear, there are many kinds of radiation, but the one that carries heat is this one. Okay. Does not require? Yes. Because it can go through a vacuum. This one. How? Force. Why force?
It's transferred from lower temperature to higher region.
Okay, it should be the other way around. Okay, good. B?
So it's 3.
Okay, nothing much for me to say. C?
Oh,
Why force?
it's in the it says that it involves changes in the densities of different regions of the fluid. It doesn't really have to be different regions.
You mean it is happening in the same region? Yeah, because the whole pod can be split into this region, that region, right? So they're still counted as regions. Yes. D? Fine. Yes, good. All right. E?
True.
Yep. Okay, nothing much I can say because it's true. Okay, good. At least you have quite a good idea now. So can you work on the MCQs?
I use. I like it. So why is the total? Thank you, sir. On 015 this is this case. So then it answer Then find the angle of find the so because it's my as what they have. The reason just about something this one. So it's a
Done. Okay, let's take a look. Okay, kinetic theory, which is what your kinetic particle theory is. Correct, your answer? B for boy. Okay, good. Can so everyone remember that word vibrate. They always want to see it. But of course, it'd be good if you remember this word vigorously as well. All right, next one, hot water tank. Hot water, that gives you a clue already. Place at the bottom because good. Okay, so look up hot water tank. Don't have to think too much. Usually it's convection. Usually. This one is a bit weird. Vacuum flask. Do you know what's vacuum flask? You do what? Okay, so what does it do? Because it prevents heat transfer, right? What kind of heat transfer? Good. Right, because there's no medium. Okay, let's go on for blah blah blah. After an hour, temperature was lower. in P, it shows that P is a better what?
Baby cup.
First thing first, P is solid, liquid, or gas? Look at the question. This is not a good color. Let me change it. Container. What do you think a container is? Yeah, so basically they are solids. Alright, so what's the heat transfer in a solid? Conduction. Alright, so your answer must include conduction. But it's not so simple. What else? What is surrounding the container? Gas, but of course normally it's air. And of course air is a gas. So from this container to the air, what kind of heat transfer? Good. Alright, so therefore, yep. I know it's a bit trickier, but you have to think like this. Yeah. Oh, which one is incorrect? Okay, let's look at it. Cool on a top map and in an open space at room temperature. Do you know what's a corp mat? You do, What does it do? Right. So in other words, it's a poor conductor. But what else is there? So we have a heated body. So I just write it as hot body. Then you have a poor conductor at the bottom. Let's use this color. Okay, this is a match. Then what else is surrounding it? Air, I would say. They didn't say anything else, right? So you can assume it's air. Okay, so what will happen? By is yes, it's air, right? Okay, good. Is there conduction? Where? The map. Okay, but yeah, there is. You're right. But let's be also realistic. So in other words, the conduction will be quite little. Okay, little. There's also conduction through the air. Yes, but it's also very little. Remember, air is a good insulator too. You're right. But it's very little. Do you think there's convection? You don't think so? Yes, but is there a fluid here? Does this look like fluid to you? Actually, it doesn't need two fluid. Remember, in a pot of water, you just have one single fluid. Okay, in this case, it can happen. You may want to take note to analyze questions like this. So for this case, your convection can also occur in the air. Okay, can ah. So therefore, if I look at the first statement, yes, good. Second, yeah, correct, because air is a bad conductor. Third statement, radiation. What are the four factors? Are these two part of the four factors?
Yeah.
Yes, they are. So it is.
Sure.
Yeah, it's true. Look at the last statement. What's why?
It's not the most effective when temperature difference.
What should the right I mean the correct version be? Yes, good. Okay, at least you understand that. Good. All right. So basically, you know your answer. Okay, can actually you should be able to understand all this, huh? Okay, just a bit of time left. See whether you can try section B. Okay, good. Let's take a look, huh? Do you notice this? Aluminum foil, you did, huh? Okay, so how? Which side is shiny, which side it should be dull? Good.
Then for part B,
One, actually, 1A is quite tricky, no? You only get half right, Yeah, you're right. But you miss out the other half. Now, here, the outside, you're right. The outside is on the outside, Let's use the scientific words. It absorbs. What? What word should you use? Absorbs. Heat, what is the proper term? I mean, you're not wrong. Barbecue fire. Yes, absorbs. Remember, did we mention absorb conduction or absorb convection? No, right? Absorbs. Yes. I mean, you want to score with all the right words, absorbs radiation well from the fire, if you want. But this, even then, this only gives you half the marks. How about the shiny side? What does the shiny side do? Yeah, you're right. But how? You're right. Just now, remember we mentioned 3 words, not just conduction, convection, and radiation, but another set of 3 words. What are those 3 words? Good. And a good absorber is also a good. We use the word emitter. Remember, emits. Okay, take note of these 3 words because try to use them in the answer. Now, shiny is a good reflector. But to be exact, it reflects radiation. Back to the food. And prevents heat loss or minimizes heat loss. Okay, Devan, so try to be sensitive to words like dull, shiny. You need to write something about them. Okay, how about part B?
absorbing radiation. Anything radiation, but
Okay, you're not wrong. There's radiation from this heater. There's radiation, but there's also something else important. I hope you notice this word. Yeah, I think you know already. Near the floor. Near the floor means bottom, right? Why is bottom good? Okay. But now here, of course, there are no marks here. So you have to write the full answer. Now, basically, remember what what you wrote just now? Now, basically, now just remember, once you see words like near the floor, near the bottom, think about convection. Okay? Alright, so make sure you have convection in your answer, but let's be a bit more than that. Let's write a bit more than that. Basically, remember air is a fluid, so air next to the heater is heated up. Then you can write the full long story. Alright, try to remember this story. So its volume increases, but I use symbols, the volume increases. So density decreases. All right, then it rises up. And loses heat. Okay, along the way. But like I said, it didn't tell you how many marks, so I just write the full story. So then, not done yet. Cool air from above sinks downwards to replace the rising warm air. It gets heated. Next. Then I always want to end with the cycle repeats. And we always remember this important phrase, convection currents are formed. Okay, that completes your story. Try to hide, I mean, all these are important points. Volume, density, rises, sinks, I mean, loses heat as well, loses heat along the way, sinks, cycle repeats, convection currents are especially important. Make sure you write that. Okay, can. Okay, I think we are almost finishing, so I'll leave this maybe for next week. I'll go through with them or something. I record it down in case you want to watch it. Right, questions for today? Okay, good, good. All right, so make sure you can do well when this part comes out in your school. Yeah, okay, can. That's it for today.